Hello, my name is Victoria Orchard, and I am an undergraduate student at the University of St. Thomas. Working in coordination with the Geography and Environmental Studies Department, I was able to produce this analysis of the spatial patterns of cholera deaths, utilizing John Snow's study of cholera as the foundation of my research. Cholera's first mention in history was over a century ago, but until fairly recently, we lacked the ability to really understand its transmission. Cholera is caused by the Vibrio cholerae waterborne bacterium when present in a human host. With cholera affecting at least 2 to 5 million people per year, it's important to discern the different factors that influence its transmission. Some of those include global weather patterns, such as the influence of sea surface temperature, chlorophyll A concentrations in aquatic reservoirs, zooplankton, which act as another form of host, and the constant changing of the bacterium itself and its relation to the host. Most of the events of cholera relating to this study took place during the year of 1854. Although our first records of cholera were in India, cases across the globe were reported as it spread east, south, and northwest. Focusing in on our study area of England, the Board of Health was not permitted renewal just as the cholera epidemic took hold in July of 1854. That year, deaths increased from 1 to 133 per week just in the month of July, and by August 12th, that number had already reached 644. This epidemic invoked the first occasion of the promotion and financing of a health department in the 19th century English government. Multiple studies then took place within a few years of John Snow's research, producing similar results, if not the same. Then, a report published by the Committee of Scientific Inquiries stated that cholera is communicable by air or water, although John Snow claimed it was purely waterborne. John Snow, said to be the father of epidemiology, studied the communication and transmission of cholera very closely. Because he was offered no accounts or collections of data, he spent large sums of his time recording very detailed information about the disease and its victims. Taking special interest in household cases, he would know even the most intimate details of the hours leading up to the deaths of entire families, which took place in just 24 hours. He soon came to the conclusion that new cases of cholera in locations that had not previously reported the disease always came geographically from the seaports and docks. This suggested once again that cholera was waterborne. The purpose of this research is similar to the work of Snow himself. Using data from the 1854 outbreak in Soho, London, I was able to target patterns of cholera deaths, including the point density of cholera deaths, mean center of cholera deaths, directional distribution, and the Tyson polygons of trade areas. By combining these features, I was able to create new maps which exhibited the mean number of deaths by trade area, providing more information as to how the disease was transmitted. If we start by taking a look at the model I used in the GIS system, you can see that many components were combined in order to produce the final map. By breaking up the model, we can more easily understand the process in which my conclusions were formed, and first we need to understand how the individual cholera deaths were mapped in relation to the model. This map shows the input data used for cholera deaths. Each dot on the map resembles the location of a cholera death, and as you can see, they are heavily concentrated in the center of the map. This is called the golden square area because of the square located around the lower left corner of most of the deaths. Using the individual deaths from the map before, I was able to use tools that provided three new maps: density of cholera deaths, mean center of deaths, and the standard deviational ellipse. Taking a closer look at the density of cholera deaths, we can see how heavily concentrated the dark red areas appear around the study area, especially towards the center of the map near Broadwick Street. Next, we can see the mean center of deaths, which again is located right around Broadwick Street. And finally, the standard deviational ellipse, which also centers the area right above Golden Square. Looking at the entire model once again, we can now focus in on the other half of the input data. This is the data for the 8 pumps surrounding the Soho outbreak. Using the Tyson polygon tool, I was able to create another map, this time depicting the 8 general trade areas, one for each pump. By adding in the standard deviational ellipse, we start to isolate the area in which the contaminated pump could be. Next, I added the mean center of deaths back into the map, showing exactly how close the mean center is to the Broadwick Street pump, leaving us with no other pump to question. By adding the pieces of the model back together again, we can see how all the different map layers are combined in order to produce one final map. Using a zonal statistics tool, I created the final map, mean number of deaths per trade area. This map resulted in a colorful depiction of the 1854 cholera outbreak. From the information gathered in John Snow's study in combination with the GIS software, I have produced an accurate spatial analysis for patterns of cholera in the London outbreak. As you can see, the Broadwick Street trade area was the darkest red, symbolizing roughly 2,700 deaths in the area on average. By revealing patterns from the cholera data, it is easier to see how the cholera spread through the Soho area. The GIS mapping confirmed that the Broadwick Street pump was indeed the pump involved in the outbreak, confirming what John Snow had been arguing since his first two-page pamphlet. In the future, it would be interesting to study cholera on a broader scale, being that the disease is endemic to more than 50 countries. Each year, 100,000 people are taken by the fatal disease, and although we have far better technology to research it now, the once common strain of cholera, Vibrio cholerae, is ever-changing and has led to the creation of many different mutations. Roughly 1 billion persons don't have access to clean water, while another 2.6 billion persons struggle without adequate sanitation every year. By looking at the infrastructural systems in place to provide clean water and sanitation, we could better describe what actions small and large-scale governments can take to combat the spread of cholera, among many other fatal diseases. I would like to point out how helpful these scholarly articles were in my examination of the spatial patterns of cholera, as well as John Snow's own book on the mode of communication of cholera. Finally, I would like to recognize the data sources and software that were used in the creation of this film.